Hello, ladies and gentlemen. Welcome to Coach Jay's YouTube session. We are underway. Can't wait. Here we go. Hey, hopefully you're making buckets like this shot right there. Let me try that again. Sorry. This is live, okay? This is live. I've been practicing this. All right. So as we get going today, if you have any questions, throw them my way. You can throw them straight on my message, and it just comes straight to my phone. I don't know what I'm doing. That shot threw me off or something. But we're going to get started. Sections, again, 1.5 or 1.6 to 1.9, and we're going to throw them up there and go through them together. So as we go through them, throw a question out there, and we will go from there. One of the ones I definitely wanted to hit on were these four. These were four of the ones that, as I had asked earlier, these were the ones that we really needed to go over based on what students had said. So we will do this one. All right, we'll make sure we get this one done and go from there. Okay, so let's do this one first. Move this over just a hair. Sure. Oh, there we are. Perfect. Okay, so let's do this. Let's go straight into number 28. Okay. So the first thing we like to do is simplify by having 2 go into 16 8 times. Okay. Now remember that with the x to the negative first, we'll keep that on the top, with y to the third on the top as well. But then we need to take x to the third and y to the negative 6 to the top side. And when we do that, we change the sign, right? So now we'll end up being x to the negative third, and then the y would be the positive sixth. Okay, remember this whole thing is still to the negative second power. We'll hit that there in a second. We're not quite there, so let's keep going. Now the x's will combine, so we'll keep that 8. So we'll have 8x to the negative fourth, and y will make to the positive ninth power. Okay, so we have 8x to the negative fourth, y to the ninth, and that whole thing is going to be the negative second power. Okay, so we just simplified the inside. Now we work the outside. One thing we note is that once the negative 2 gets distributed, a power to a power gets distributed there to where x would be to the positive 8, y would be to the negative 18th, and 8, this is where it gets a little tricky. You can't forget about the 8. 8 is going to be the negative second. Okay, so if I were to simplify this, really all the negatives go on the bottom, positives stay at the top. So you have x to the 8th over 8 squared, y to the 18th. So we make these both positive, okay? So in simplifying this, we get x to the 8th all over 64, y to the 18th. And that right there would be my complete answer for number 28. Now 29 is one that is definitely different. One thing that I think I would do on this is just to kind of set it up in the right way. Let's take the 3 out just so that we can do it that way. And we're going to rationalize this by multiplying by 1 plus square root of x, okay? The reason why I took out that 3 is to give you something that kind of mirrors the test a little bit better. Now once I distribute by 2, I get 2 plus 2 root 6, or root x, I'm sorry, all over 1 times 1 is 1. Okay, 1 times square root of x is square root of x. Someone just texted me that they're good, so I'm glad we're there. Again, if you have questions, throw them out there, okay? I'm starting on the review ones, but hop in when you need some help there. Negative root x times 1 would be negative root x, and negative root x times positive root x would be negative x there. So the positive and negative cancels, leaving me, the top would be 2 plus 2 root x all over 1 minus x, and that would just be kept as is. Now, if this was a square root of 3, we would do it the same way. If I had 1 minus square root of 3, I'd multiply by 1 plus square root of 3, and with the goal of getting that square root out of the bottom. Okay, awesome. Now look at the next part. This 375, the number that's here, we want to kind of divvy that up. So if I kind of took 5 out of there, I'd be left with 72. 72 can divvy out to 9 and 8. 9 is 3 and 3, and 8 is 2, 2, 2, right? Because 3 2s on that. Can I add? I'm sorry. I just saw a message here. The message reads as follows. Can you add the 2s or no? Because one has a squared with it. I'm trying to see on that. I'm sorry. If you could give me a screenshot of that, that would help me on that one, on number 29. So just stop it at the video and then let me know because I can't quite see that. So just let me know on that once you get that. So once we divvy these up, we have now the factors of 5, 3, 3, 2, 2, 2. Again, we have x to the 7th and y to the 15th. And remember, we're looking for groups of 3 because of the third root. So a group of 3 would be 3 2s. So we're going to pull a 2 to the outside, and we're going to be left with, on the inside, a 3, and a 5. So that'd be 9 times 5, which is 45, okay? All right? So then what we have is x to the 7th. We say how many groups of 3s do we have in x to the 7th? And we have 2, right? And if you need to write them all out, you can. It's not necessary, but you can kind of write them out. You see 2 groups of 3. So we have x squared on the outside and 1 left over by itself, all by itself on the inside. Okay? Y to the 15th, how many groups of 3 do I have? I have 5 groups of 3. So I have 2x squared and then the third root of 45x y to the 5th. And that right there would end up being what my answer is for number 30. Okay? Awesome. Oh yeah. As far as that goes, what I'm looking at, the picture for that person that sent that message, yes, you cannot add those because one has a square root and one is just by itself. Okay, great question. Okay, let's look at this one, 31, top left. Let's factor first. Teach me how to factor. Teach me how to factor. All right, we're gonna factor top left and 2 numbers multiplied that equal 2, added equal -3. And that would be x minus 2, x minus 1. On the bottom, 2 numbers multiplied that equal 5, added to equal -6. And that would be x minus 3 and x minus 2, be on the bottom left. So we got that there. On the top right, we could pull out an x, leaving us with x minus 25. So we'll keep that on that side too. And on the bottom right, we have x plus 2 and x minus 2. Now we look and see, is there any of these that we could cancel out? Well, we got an x minus 2 that we could cancel. But other than that, there's really nothing else. So all we could do is just leave what's on the top there. So x times x minus 1 times x minus 25. And then on the bottom, we get x minus 3 times x plus 2 times x minus 2. Okay? And that would be our answer in terms of 31. Okay? Gucci. Okay. If you have any other questions, again, stop me, please. Okay. The one that I did also want to go through was this one where this 9 would turn into an 8 and make it a little bit easier for what we'll face on the test. First, what we want to do is we want to pair the x's together. So we have x squared minus 8x, and we're going to close it off. And then we'll have y squared plus 2y. Again, leave some room and close it off. Equals, and this is where we're going to add 5. Okay? All right? Awesome. Perfect. Okay, gotcha. On the chat, let me see if I can go to the chat. I usually don't pull that up, but I can see if I can. See if it's on the chat here. If you all can see this, for some reason I'm not able to see it on there. I could see myself, but I'm not able to see anything else on there because of the YouTube, the way the YouTube works there. If you could send it to a 770-757-2240, that would be awesome, and that way I can see that. Or if you see someone else's question on the chat, you can also post it on there as well. Okay. So once I put this on 27, like so, we want to take the middle term, which is -8. We want to half it and square it. So if we half it, we get -4. And square it, we get positive 16. But what I do to one side, I got to do to the other as well. Same thing holds true for this too. I half it, which would be 1. I square that 1 to get positive 1. What I do to one side, I also do to the other. okay? So on the right side, I get 22 when added. And when I factor here, two numbers when multiplied get me 1, but when added get me 2. Remember, it should be the same exact number, okay? So y plus 1, y plus 1. And then the x would turn into two numbers multiplied equals 16, but when added equal -8. So I'd get x minus 4 and x minus 4. So what it would be is x minus 4 parentheses squared plus y plus 1 squared equals 22. So if I was finding the center would be the first number set it equal to 0, I get 4. Second number set it equal to 0, I get -1. So 4, -1 is my center. And remember the radius, this is r squared, okay, equals this. So if I was finding the radius would be r squared equals 22. So r would be actually the square root of 22 there, okay? So I have my center and I have my radius. All right, hope that helped out there in terms of finding that and going from there. I do have a question that is posted. Sorry, how did we get the bottom 3 2? Okay, I'm trying to think. Okay, number 30. Let's take a look at this. Okay, let me go back. Let me go back to number 30. Why was the bottom numbers 2 and 3 and not 1 and 5? Okay, so 2 and 3 and not 1 and 5. What are the bottom numbers? I'm confused on that one. Yes, I'm confused on the question there. As far as how I broke it up, man, I'm trying to think. So when I broke it up, I had 3 times 3 times 5 times 2 times 2 times 2, right? I knew I had a pair of 3 twos, so I'll pull a 2 to the outside, right? And I believe that was it. And then whatever's left on the inset, 31. Okay, I was like, what is going on? Okay, excellent. So what we're talking about, the question is, why was the bottom numbers 2 3 and not 1 5? Ooh, because Coach J is wrong. That's why. Nicely done. Way to catch that. Okay, what Laura was saying was, I actually messed up on this, because this should be x minus 2, x minus 1, which I did. And when it's on the top, multiplied by x times x minus 25. This is my fault here. I went too quick. Two numbers multiplied equal 5, added equal -6. That should be not 3 and 2 because it can't multiply to equal 5. That was in my head. Should be x minus 5, x minus 1. That looks a lot better. And then we have x minus 2 times x plus 2. That probably looks better to where I could cancel here, 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 and here. There we go. And we get x times x minus 25 all over x minus 5 and x plus 2. Thank you, Laura, for that. I appreciate it. I'm completely messed up on that, and you're right. And that's why for this one, it's really important to go through and check it, because anyone can mess up on that, okay? So just be sure on the factoring, you check it, and then come back through and double check it on that. Thank you. Thank you so much. Okay. Any questions on this? Remember 26. I'm kind of going backwards right now. I didn't plan on this. But remember that this is the standard form. And by the way, if you have an extra question, please post it. Remember 3 goes in for H. -2 goes in for K. So it would be x minus 3 parentheses squared plus y minus -2, because -2 goes in for K. So it'd be plus 2 squared equals, and then we'll plug 7 in for my radius here. So once I plug 7 in, 7 squared is 49. So that's how I would get the following circle that you see here, the circle formula, I should say. Okay? Good, 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 good. The distance formula, just a heads up on the distance formula. Square root of x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. Remember that the x2 could be either one as long as it's consistent. So we could say -12 minus -2. So -12 minus -2 parentheses squared plus And then -1 minus 4, that's y2 minus y1. A lot of you know how to do this. But this would be -12 plus 2, which would be -10. Square -10, I get 100. On this right side, -1 minus 4 is -5. Squared, I get 25. So I'll add these two together, 100 plus 25. And what I'll do is I'll do the square root of 125. Okay, so if I did that on my calculator real quick, should be like 11 point something, but it will be on your calculator when you plug that in. Should be 11 point something like 3, something like that. If I did 11.3, yeah, probably about 11.3, probably 11. Let me see, 11.2. My calculator's coming up. That's why. Yeah, I would say about 11.2 approximately, give or take there. But that would be the approximate distance there for that. Midpoint, remember the midpoint formula. If you need help on that, we'll do that before class tomorrow. But that's x2 plus x1 divided by 2, comma y2 plus y1 divided by 2 as well, okay? Plus y1 divided by 2. So that's the midpoint where this is the x and this part's the y, okay? All right, man, y'all are rolling on this. 24, I think we hit a lot of those in class. I wanted to give another one like 23 up here. Let's say that I have 2x plus 1, and that's f of x, right? And this is another one like 23 up here, okay? And let's say g of x is equal to 1/2 x. And let's say h of x is let's say x minus 1 divided by 2, okay? So we're trying to determine which one are inverses of each other. So remember to determine this, we'll have one of these. And yes, I'll do 16 in a second. We'll do this one and then 16. What we can determine is if we plugged in one of these in for the x of another, we could know that it produces x. So let's say that we plug this f of x in for the x of g of x here. What we would get is, by the way, that would be, if I were to write this, I don't need to, but that's what that would look like, where f goes in for g. So what would happen is 1/2 times 2x plus 1, close it. So 1/2 would be multiplied by 2x to get x, and 1/2 would be multiplied by 1 to get 1/2. So x plus 1/2 is my answer, which means they are not inverses. Remember, it must equal x. So what we're going to do is we're going to do the first into the last one. So we're going to put it in for this x here, which would be h of f of x. That's funky, I know. But what I would get is 2x plus 1, close parenthesis, minus 1, because all it is going in for this x here, okay? No, you don't always have to do f in for g, because you're going to see in a second that when I do h of f or h composite f, we can plug 2x plus 1 in for x. And when we do that, this is not multiplied, right? Because these aren't piggyback, they're just subtracted. So you can actually take the parentheses away. So I have 2x plus 1 minus 1. 1's cancel, giving me 2x over 2, which produces x. What does that mean? Well, that means that h and f are inverses of each other. But we need one more thing. This time we've got to plug in f of f composite h, which means that h, this x minus 1 over 2, gets plugged in for the x there. So that means that this time it's going to be 2 times x minus 1 over 2, okay? And plus 1 on the outside. So 2's cancel out, leaving me x minus 1 plus 1, which produces x. So that means these two are inverses, the first and the third, are inverses of each other by proving that when we plug one into the other and vice versa, it produces or equals x. Boom, shaka, laka. Okay, let's go to 16. Okay. All right, yeah, 16 is one that's just, man, it's weird a little bit, mainly because it's not really anything you can do to simplify this thing. Really what you would do is plug in x squared plus 2x plus 3, and you would plug in 3x minus 1 and for the bottom. And when I do that, that's my answer. I know that that's really tricky, but that would be my answer. Now, what if I did like plug it in? Let's say I get x squared plus 2x plus 1 all over x plus 1. And on the top, you could factor, okay, to get x plus 1, x plus 1. And what you could do is actually cancel out 1 to get just simply x plus 1 as my answer. You can do that like on 16. That's possible. You could do that if I gave you one like that, but I can't factor out x squared plus 2x plus 3. And even if I did, there's nothing that would be able to be canceled out. There's no 3x minus 1 on the top I could cancel out there. Okay? Excellent. That's really good. Another one I wanted to hit on, number 22. Remember on this one, we're looking and seeing what can I take out. Whatever I can take out is my g. Okay, so whatever I take out is my g. So I'm going to take out x minus 3. But when I take that out, I leave it to where now I have left x squared minus 1, right? X squared minus 1. So if I plug this in for x, it would produce the original answer. So what we would say is g of x is x minus 3. X squared minus 1 is f of x. So that would be number 1. And that would be number 2. That's just a way just to find. Again, this is called composition of two functions, where I give you function h and you're trying to tell me what f and g are there. Okay? Good. By the way, as we go through them, keep bringing them my way, okay? Keep bringing them my way. Number 20. Oh, man. Actually, 19 and 20. Man, I have these circled because they are a doozy, okay? If you're at home crying because of 19 and 20, I understand. These are tough, okay? Don't cry. But if you were to cry on one, it would be this one. This one's tough just because how do I start? That's the big thing. I don't think they're extremely difficult. It's just how do I begin it? So like G, composite G, means that we're going to put 2 G's here. So 2x minus 3. And then we'll put a second, which is also 2x minus 3. Now, what this means is that a G is going to be plugged in for the other G, meaning the 2x minus 3. Yes, that's exactly right. I just got plug G in for G. That's right. Plug G in for G. All right. So we're going to plug it in, plug it in, plug it in. Sponsored by Glade, by the way, where your house smells freshly new. Okay, so we're going to plug it in to this other x. So what we have now is 2 times 2x minus 3, and then minus 3 on the outside. Remember, it just goes in for that x. It replaces it. So now we distribute to get 4x minus 6 minus 3. So when we simplify, I'm going to get 4x minus 9, and that right there would be my answer. So I would get 4x minus 9 for number 19 there. Okay. Now, as far as number 20 goes, G inverse. Remember that when I have y equals 2x minus 3, the first thing I want to do is flip-flop the x and y. So what I would have is x equals 2y minus 3. Now, once I set it up this way, I'm going to solve for the new y. So when I flip-flop it, solve for the new y. So I'm going to add 3, okay, add 3. To get x plus 3 is equal to 2y. I'll divide by 2, to where the inverse of g, and you might say, Coach, why'd you do that first? It's because you automatically saw that g to the negative 1, which stands for our inverse, right? So that's what we're trying to do, is get that inverse, which would be that right there, okay? So this right here is g inverse. Now, we know that since we found this, what are we going to do with it? Well, remember, f of x is 2x plus 5. So we're going to take this bad boy and we're going to plug it in for x. So that x right here, we're going to plug x plus 3 over 2 in for it. So when we do that, we'll have, and I'll put it over here, 2 times x plus 3 over 2 plus 5 on the outside. Again, I think you're getting the hang of it. Out the last one plugged in the first one. 2's would cancel, and I would have x plus 3 plus 5, which would be x plus 8. And we remember that the 2 that's left over on that outside now gets plugged in for this x here, equaling a total value of 10. Okay? Yes, so this is this green one right here. This is the G inverse. You kind of can see it. I'm sorry. That's the G inverse right there. And that's why it's plugged in for the f, the regular f equation, right? Because this is not f to the negative first. It's just f. And that's it. So you would leave that as is. on that. That's how you would approach it. That's how you would do it. Okay. Excellente. Remember too, and again, keep giving me questions. Y'all are doing great. Number 17, throw out. Just a heads up there. This one, number 18, you don't have to find the inverse of this. This one is where I'm plugging the F, right, in for the G. So this is going to go in for the X of the G, right, because it's plugging in for it. So it'd be 3 parentheses, x squared plus 2x plus 3, close it, and then minus 1 on the outside. So that's just a heads up on that one, just to make sure you kind of get it going forward. Okay. Fifth time, all right. 15, we're going to plug it in. X squared plus 2x plus 3. And we're going to multiply that by G, which is like 3x minus 1, okay? So that's the game plan. So we're going to distribute this thing. So we're going to go x squared to each. And when I do that, I get 3x to the third. X squared times negative 1 is negative x squared. Now we go to 2x. 2x times 3x is 6x squared. Okay, just distributing. 2x times negative 1 is negative 2x. Now last one, right? 3 times 3x is 9x. And 3 times negative 1 is negative 3. So now we add like terms to get 3x to the third. Right here, this is negative 1 and plus 6. So we have positive 5 x squared. Negative 2 plus 9 is plus 7x. And then minus 3 on the outside. So this whole thing would be the answer for number 15. Just giving you a heads up on that. Number 15, that's how you would do that one there. Number 14, just be sure when you do f minus g that the negative distributes to both parts of the g. That's the one thing that I've seen people mess up on. So please make sure that you remember that. Okay. Awesome. Gucci. Okay, man, we are rocking. This is awesome. This is good stuff. I would have no better way than math on a Tuesday night. Okay. What was that song on a Tuesday? On a Tuesday. I know y'all appreciated that. That was worth your admission to this podcast. And those from Sweden, if you don't know that song, go on Spotify, YouTube, whatever y'all do over there. Okay? All right. All right. So let's do number 11. Y equals 1 over 2x plus 1. Okay? The later we go, the crazier I get. Just heads up, okay? So on number 11, the first thing we do is we flip-flop x and y, okay? Now let's do it. So let's do it first for the inverse. We'll get x equals, 1 over 2y plus 1. Now, just a heads up, our goal is to try to get the new y, right? That's the goal. We're trying to get that by itself. So in doing that, we got to get all of this junk off the bottom, and we do that by multiplying by 2y plus 1, okay? So let's do that thing. Multiply by 2y plus 1. That cancels here, little cancel party. So we have on the left side, 2y plus 1 times x equals 1. Now, I told another class, I forget which one, I told them you could do a couple things here, but really 2 things. I like to distribute that x, so let's do that. Let's go x times 2y and x times 1. So we get 2yx plus x equals 1, okay? Remember, we're trying to solve for this y here, right? Whatever we can do to get rid of that. So let's subtract this x to the other side. So now we've got 2yx equals 1 minus x. So since we have all this multiplied, we can break it up by dividing by everything that's not y. So we can divide by 2 and x. Okay? So we divide that out. We get y inverse equals 1 minus x all over 2x. And that right there would be my answer. And that's it. Boom shakalaka. All right. We got that one. Do we need number 12? we're about ready to move. I think I hit the domain ones pretty hard last time. I hit these really hard. If you need some more help on those, you can text in if you want to. The big thing is if it's underneath the square root, so like the square root of x plus 4, I said x plus 4 greater than or equal to 0. And I know I'm going quick through this. Just subtract 4. So the lowest value is -4. The highest value, should be positive infinity. So what we have is -4 to infinity. Remember on this one, we factor first on just the bottom we're focused on because it can't be equal to 0. And when I do that, I get x minus 4, x minus 3, or x plus 3. So I set them equal to 0, and I know x cannot be equal to 4 and -3. And so when I set this up, I go from negative infinity to -3, -3 to 4, and 4 to infinity. And all three of those wouldn't be included within my interval notation for my domain. So that's just a heads up. I'm trying to give you just a bunch of little things there. Again, I hit on a lot of that stuff, hit on that there. And I'm going to go straight into some graphing. Is there anything else that I need to cover other than the graphing that maybe you feel like, man, I need some extra help on that? All right, awesome. I think number 3, I did pretty well. Number 5, I pretty much did that one in class. Number 4, I'm going to do one similar to number 5. That's kind of related, so that we kind of just have something here. So I'm going to set this equal to 2, absolute value. I think I did an inverse down here, but if I need to do number 12, let me know, okay? So if you say, Coach, I need number 12, give it to me, and I will do that for sure, okay? All right, so let's talk about this first, this graph. So a couple things you'll need to remember. You'll need to know how to do domain and range. You'll also need to know how to obviously graph it. And that's kind of the two things you need there. So remember, since this is positive and absolute value, this thing is going to have a V that goes up and down like so. And because this is x plus 1 on the inside, we know this pushes it left 1. Okay? All right, so I'm going to go left 1. And this -1 goes down 1 as well. Okay? So my starting point's left 1, down 1. So I'm going to start at -1, 1. So that, if I was looking at that, that's kind of my minimum point right there. Remember, this 2 that's attached, that's multiplied, has no bearing on left, right, up, or down transformation. What it does do is it makes it skinnier or wider. If it's a higher number, it's skinnier. If it's a lower number, it may be wider. So that's kind of where we are headed. So now we create a little t-chart here. All right, we plug in a value or 2. So we might want to plug in like 1 is a good one. So 1 plus 1 being 2, absolute value of 2 is 2. 2 times 2 we do after the absolute value would be 4. Minus 1 would be 3. So we're going to go to 1, 3. So this graph's going to go here. To kind of know, because I know it's going on this side, we know it goes 1, 2, 3, 4, and then over 2. That means it's going to go left 2 on this side. So it should look, something like that. So if I found the domain, the furthest left to the furthest right is -infinity to infinity. And the range would be the low to high. Kill them would be -1 to infinity. And that -1 would have a bracket there. All right. Okie dokie. I did say that I would do number 12. Let's go to number 12 because it is such a beautiful problem. This one is y equals 8x to the third minus 125. Again, the same thing occurs. We're trying to switch x and y right here. And we can solve for the new y by first adding 125. And what we get is x plus 125 equals 8y to the third. So we want to get y isolated, and we can do that by dividing by 8, to where we get x plus 125 over 8 equals y to the third. I can get 3 by itself by taking the third root of both sides, to where now y is equal to the cube root of x plus 125 over 8. Now, I talked to Will earlier in class, one of my students in class. about how you could actually simplify this by taking the cube root both top and bottom, and that would be fine, but I would accept this answer as well, okay? I really would accept this answer. So you would keep it as is. The big thing is switch x and y, solve for the new y. If you do that, you're going to be Gucci every single time. Got me? All right, let's go to another graphing one. And if you see one on here now, we're going to, for the next about 8 minutes or so, as we wrap this thing up, if you have any questions, I'm going to kind of do 1 or 2 more of the graphing ones. And then if you have other questions on, man, coach, could you do one like this or this? I'm going to open it up. So even though I'm working on one, this is kind of the final roll call here. If these 2 next problems are done and no questions are asked, I'll assume that we're ready to go, okay? All right, even you from Sweden, all right? Awesome. So what about number 1? With no number in the front, we know that for this one, it's not going to, we know that the negative is going to push this down. And because it's squared, this thing is actually going to be a downward parabola that normally would start at 0, but because of the x minus 2 would be pushed to the right 2. So if we were looking at this, this is like the top of the actual parabola that we found. Now, just like we did before, we're going to create a t-chart. Love t-charts, dream about t-charts. And I'm going to plug in 0. You could do whatever you want there, but I'll plug in 0. So 0 minus 2 is negative 2. Negative 2 squared. I don't apply the negative until last, right? Because I got to do order of operations. It's just giving you a heads up. So I got to do negative 2 minus 2 is negative 4, right? Oh, I'm sorry, this is 0, my fault. 0 minus 2 is negative 2. Squared, I get 4, then apply the negative. So I'll have negative 4 here. 0, negative 4. This is going down, so it goes left 2, down 4. And we know it's going to do the same thing this way, so we're just going to mirror it over. Or if you want to plug in 4, you could, but if you plugged in 4, you would also get negative 4, which would end up being right here, okay? So that would be my parabola going downward, and that would be it right there, okay? Let's go through, actually, I'm sorry, domain and range. Domain, negative infinity to infinity. What would be the range? I want you to yell it right now. I don't care. People look at you weird. That's okay. People look at me weird too. Negative infinity to, yell it out, 0. Remember that this one, even though it's at 2, we're looking at the y. The highest would be 0 with a bracket because it does hit on there, okay? Last but not least, I started 0, 0. Because of the x plus 4, I transform that. Left 4 and then negative 2, since it's on the outside, I go down 2. So left 4 and down 2. So I'm going to go left 4 down to 2. Okay, so I start here. Remember with the square root, if it's positive, it's going to kind of go out this way. So you can expect kind of like an arrow to be shot out in that direction. So we go to our little t-chart here, x and y. We want to plug in 1 to like the right, so maybe like 0 would be a good one. So I go 0 plus 4 is 4. The square root of 4 is 2. 2 minus 2 is 0, so I'll put 1 there. Think of a number 2 that I could take the square root of evenly, like 5. So 5 plus 4 is 9. Square root of 9 is 3. 3 minus 2 is 1. So what we have here is 5, 1, 0, 0, and then obviously negative 4, negative 2 is my starting point. So this graph would go on and on to the right direction. So our domain is a little different. Furthest left would be negative 4. Furthest right is infinity. Range, the lowest is negative 2. And the highest is infinity. Okay? And that would be my answer. Hopefully, do you all have any other questions? Have we done 26? That's a good question. Yep, 26 is right here. Remember, h is, in this case, 3, right? 3 goes in for the h, so it's x minus 3 squared. It's opposite of what we did on 27. I think it's easier on 26 than 27. And then the same thing, negative 2 goes in. You'll get this form right here on that. So just plug in h and k and the radius r. Remember, don't forget to square that radius. Just like when I give you this number on the outside, you square root it to get the radius. If I tell you the radius, you've got to square it when you plug it back in, okay? Perfect. I've not gotten any other questions at all. Trying to see if there are any other questions. I'm looking through. I don't see any. All right. Well, Coach Jay, signing out. Have a fantastic day, and we will see you tomorrow. Have a great day. Maybe next time. Bye.